Now that we've simplified numeric roots, I want to talk about what happens when you're trying to simplify algebraic roots. So the difference here is instead of just having numbers under the radical, you're also going to have variables. So the numeric piece doesn't change. You're going to keep doing what we talked about in previous videos. You want to find what's perfect about them. So 54, so you're looking for perfect cubes because it's a cube root, and it is helpful when you're doing this to have that list close to you. The perfect cube that goes into 54 is 27, so it's 27 times 2. And I'm going to actually start doing this a little differently. I'm going to start putting like a box around the part that's perfect because that's going to help me with my variable. So here's what happens with my variable. I want to revisit the idea of taking the power dividing by the root. We've talked about simplifying that way, power over root. So when I'm simplifying a radical, I want to get it to the point where it's a power that is divisible by the root. So when I do power over root, it divides evenly. So when I look at the power of x right now, it's 5. 5 does not divide by 3 evenly. We would not say 5 is divisible by 3. So then we drop to the next power lower than it and try 4. 4 is also not divisible by 3. So we drop again and we get it to be x to the third. 3 is divisible by 3. So we're going to break this x to the fifth off into x to the third. And then if we use 3 of them and we start with 5, then we have a leftover x to the second. This is the perfect piece. So we have the perfect piece, which is the piece that the power is divisible by the root, and then we have the leftovers. We do the same thing with the numbers. We have the perfect piece and we have the leftovers. And some students like to mark both. Some people like to underline the leftovers. I like to put a box around the perfect. To finish these problems, you're going to take the cube root of anything that you put into a box, anything that you said was perfect. So the cube root of 27 is 3. And the cube root of x to the third, again, you do power over root. So third power, third root, you end up with just x to the first. When you take the cube root of that, they come out front. The stuff that was not perfect is stuck permanently under the radical sign. So we're doing a breakdown not only of the number and trying to find the perfect parts, but also of any variable that is there. So 128 is not a perfect cube. So let me look at my perfect cube list. I feel better when I have that reference. So 128, 64 goes into that. So I'm going to break that down into 64 times 2, and I'm going to put a box around the perfect. And then I'm going to do the same thing with 7, because x to the 7th, 7 does not divide by 3. But if I drop it down to 6, if I go one power lower, 6 does divide by 3. And then I will have an x to the first left over because I'm going to take that 7th power and split it up into x to the 6th because that's the biggest perfect number, and then x to the first. Take a cube root of the ones that are in the boxes. So the cube root of 64 is 4, and the cube root of x to the 6th, you're going to do power divided by root. You're going to get x squared. And then the non-perfect parts, which are going to be the 2 and the x, are left underneath the cube root. Next one is a fourth root. So now when I look at my list, I need to look at my list of perfect fourths, and I don't have a lot of them, I should know. Let's see. So 16, I think, is the one I'm using here. So 16 does go into 64. It's 16 times 4. 16 is the perfect fourth. It's 2 to the fourth. X to the third. Here's the deal with x to the third. It is not perfect because 3 divided by 4 is not divisible. But the problem is it's actually too small. There aren't enough x's to be able to divide evenly. So this is going to be permanently stuck under the radical. This is going to be stuck under the radical. The y to the 6th, so that's not perfect because 6 doesn't divide by 4 evenly. So we're going to have to drop that down to y to the 4th with a leftover y to the 2nd. This is perfect because the power divides by the root. So I'm going to take the 4th root of 16, which is 2, and I'm going to take the 4th root of y to the 4th, which is y, and then what was not perfect, the stuff that I underlined, the 4 and the y squared, and the y squared and the x cubed. Sorry, I forgot about the x cubed. They don't have to be in alphabetical order. So your 4, your x cubed, and your y squared are all stuck underneath. So that's how you simplify basic algebraic roots. You're going to use your reference list for the coefficients for the numeric piece, and then you're going to use power over root and see if you can get the power to be divisible by the root. You will have some leftovers if they don't divide evenly, and those leftovers stay under the radical.